In this lesson, we're going to talk about volume. Volume is the measure of the amount of space inside of a solid figure. Basically, if we had a three-dimensional figure and we wanted to fill it up with something such as water or sand, we would need to know the volume of the object. So we're going to talk about two different shapes today. The first shape is a rectangular prism. You can see that it looks kind of like a rectangle, but we call it a prism because it's three-dimensional. So I want to focus your attention really quickly here to the top right-hand corner. Notice over on the right corner here, I have the formulas. This can be found on your formula sheet. So you want to have that out as we work on this section today. So you can see that this picture is the picture of a rectangular prism, and underneath of it there are two formulas. One is for V, which is volume, and the other one is for SA, which is surface area, which we'll talk about in the next section. So I just want you to focus on this first formula. The formula means that volume equals length times width times height. You can see that a rectangular prism has a length, has a width, and has a height. And if you multiply all three of those dimensions together, you will get the volume of the rectangular prism. Let's go ahead and try to see if we can calculate the volume of these two rectangular prisms below. All right, let's look at the first one. The first one, you can see here that we have a rectangular prism, and you can see that we have a length, a width, and a height. Now, what's really nice here is that it doesn't matter which one of these you label length, which one you label width, and which one you label height. As long as you label, a length with one of them, a width with one of them, and a height with one of them. So I'm just going to take what looks like the length to me. And it looks like the 8 right here is the length. So I'm just going to go ahead and label it length. And then we have a width and a height. So I would probably say that the 5 centimeters looks like a height to me. So I'm going to put an H there. And then, of course, my 2 is going to be my width. I always like to start by labeling them because that makes it really easy to pop it into the formula. Okay, now let's go ahead and start. I always start with my formula because that's half the battle, is figuring out which formula to use. As we start accumulating more formulas, it's going to be really important to make sure that this is your first step. So I'm going to go ahead and just write volume equals length times width times height. Okay, now what I want to do is, we learned this way back in a previous unit, is we always like to put parentheses around our variables because we're going to substitute numbers into them. So I always like to take the extra step and do this and just put parentheses around my variables just to separate them. We do know that there's multiplication between these three variables, so let's go ahead now and substitute them in. Volume equals, my length is going to be 8 centimeters, my width is going to be 2 centimeters, and my height is going to be 5 centimeters. Now all I need to do is, I like to just call plug and chug. I plug them in, now chug out the answers. We talked about this way back in the first unit on how to multiply these numbers. You can do them all together or you can break them up. Here's what I mean by break them up. We could do this. 8 times 2 is 16, right? And then we're going to multiply that 16 by 5. So it's kind of like a two-step process in a way. So I'm just going to go ahead and write it like this. Volume equals, and then 16 times 5 is 80. Now, we're not quite done. We always need to have our units. So our units, you can see here, up on our rectangular prism, we have centimeters. So I'm going to write centimeters. But remember, centimeters is just a dimension that we have, like length, width, and height. It's just a one dimension. But you can see that this dimension, as we talked about earlier, is 3 dimensions. So if you have a 3-dimensional figure and we're looking for the volume, we're actually going to cube this, meaning we're going to raise it to the 3rd power. All right, that is the volume of my prism. What that means is that if we had 80 centimeters and we cubed them into tiny little cubes, 80 of them would fit into this rectangular prism, which is kind of cool. Let's look at the next rectangular prism. This one is a very unique type of rectangular prism. It's called a cube. You probably have seen this before. But the unique thing about a cube is that all of the side lengths are equal. So you can see here that they only give us one dimension. They only give us 4 centimeters. But because we know that it's a cube, we can also say that all of the other side lengths are 4 centimeters as well. So now let's go ahead and set up our problem. We know that this is a prism, so I'm going to go to my formula sheet and I'm going to go ahead and grab my rectangular prism, which is what you see up at the right-hand corner. I'm going to go ahead and write down my formula. Volume equals length times width times height. Now again, they only give us one dimension, so really this is my length, this is my width, and this is my height. So I'm going to go ahead and I'm going to pop that into my formula. I'm going to start by just putting parentheses because I always like to take an extra step. I'm going to say volume equals my length, which is 4, my width, which is 4, and my height, which is 4. And again, we can go ahead and we can break this down a little bit, and we could say 4 times 4 is 16, and then we're going to multiply that last 16 by 4, which is going to give us 64. Now that length and width, remember, this right here is 4 centimeters and 4 centimeters. All of these lengths and widths are all 4 centimeters. If you'd like to label it like I just did, feel free. All right, now let's go ahead and finish our label. 64 what? Well, 64 centimeters. And anytime you're dealing with volume, you're going to cube your answer. So 64 centimeters that are cubed will fit into this rectangular prism. All right, let's go ahead now and look at the other shape that we're going to look at today. And this shape is a cylindrical prism. So this is a cylinder. So kind of like a soda can. You can see here up at the top that we have a different formula. So on your formula sheet, locate this figure that you see here. Now, just looking at the blue formula first, you can see that we have our cylinder, and then we have a volume formula, and we have a surface area formula. And then we have this little pink thing off to the side, and we call this pi. And we probably just celebrated Pi Day, which is the constant 3.14. So we're going to use 3.14 as pi when it indicates that. So let's go ahead and look at the cylinders below. These are 2 unique cylinders. Let's look at the first one. So you can see that it's kind of a cylinder on its side. That's okay. So what we need to do is figure out the volume formula, which we can gather from our formula sheet. Volume equals pi r squared times height. Now, we already talked about pi. Now, what is the r? The r represents the radius. The radius is, if you have a circle, we talked about this in the last section, but just as a review, if you have a circle and you have the center of the circle, the radius is a line that reaches from the center of the circle to the edge of the circle. That's the radius. Now, if you wanted to talk about the diameter of a circle, you still have that center of the circle, but the diameter goes through the circle and reaches from side to, or goes through the center and reaches from side to side. So basically the diameter is twice the radius. So we're going to need the radius for this formula. And then of course you have the variable h, which is our height. So let's go ahead and calculate. We can see that we have a 12 and a 2. 12 is going to represent our height. Even though it's on its side, that's if you were to tilt it back, on its front side, that would still be the height of our cylinder. 2 is going to represent our radius because it reaches from the center to the edge length of the circle. So let's go ahead and label him R. Now let's go ahead and calculate. Here's our formula. V equals pi r squared times height. Now let's plug in actually I'm going to go ahead and start here first. I'm going to go ahead and I'm going to put some parentheses around my variables. Remember, parentheses only go around the variables, not the exponents. All right, here we go. Ready? I'm going to go ahead now and I'm going to change pi to 3.14 because I know that that's a number that we're going to use. My radius is 2 and my height is 12. Now, the way that you calculate this is very specific. You have to use PEMDAS. So PEMDAS, remember, we always do our exponents before any multiplication. So I'm going to start here. 2 squared is 2 times 2, which is 4. So I'm going to go ahead and bring everything down, just like we learned when we talked about PEMDAS. And now we can go ahead and simply calculate. Now, because this has a decimal in it, I would just break this down into pieces here. You can do 3.14 times 4, or you can even do 4 times 12 first if you'd like. I'm going to do 3.14. So 3.14 times 4 is going to give me 12.56 times 12. I've got one more step. Let's go ahead and multiply it by 12. So I've got 150.72. So 150 and 72 hundredths. I have to label it. So because I'm talking about volume, I'm going to say centimeters cubed. And that's how many centimeters cubed is going to fit into this cylinder. Let's try another one. This one's slightly different now. Now, look what they give us this time. We can see, obviously, that we have a height of 8 on this cylinder. But what about the 6 centimeters? 6 centimeters is the diameter, which means that we actually have to do something. We have to take this 6 and we have to divide it by 2, right? Because the radius is only half of this. So what's our radius going to be? Our radius is going to be 3. So let's go ahead and use that information. Volume equals pi r squared times height. And I'm going to go ahead and I'm going to say pi times r squared times height in parentheses. And let's go ahead and change it. 3.14 times my radius, which is 3. Be careful not to put a 6 in there because the 6 is the diameter. And my height is 8. All right, let's go ahead and calculate using PEMDAS. I'm going to do my exponents first. So volume equals 3.14 times 9, right? 3 times 3 is 9. Be careful not to say 6. And then times 8. Now, I could say 3.14 times 9, but I'm actually going to do 9 times 8 first, just to show you that you can do this. So volume equals 3.14 times 72. Now let's go ahead and just finish it up. Volume equals 3.14 times 72 would give us 226 and 8 hundredths. And I'm going to label it centimeters cubed. And that's the volume of my cylinder. So now that we've talked about the volume of rectangular prisms and cylindrical prisms and how to use those formulas, let's go talk about some applications of this concept. All right, let's look at this first question here. The table shows the dimensions of 4 rectangular prisms. Which rectangle has the greatest volume? Okay, so first thing we know what we're looking at is a rectangular prism. So automatically I can go ahead and write my volume of my rectangular prism is length times width times height. I grabbed that right off of my formula sheet. Okay, and I knew that because it says rectangular prism. Now I want to know which one has the greatest volume. Greatest volume means the biggest volume. So what we need to do is we need to figure out the volume for rectangular prism A, B, C, and D. Let's go ahead and do that. Notice in the table it gives us our length, our width, and our height. So let's go ahead and calculate the volume of rectangular prism A. So if we were to say the volume equals length times width times height, wouldn't that equal 2 times 6 times 3? So what's our volume there? 2 times 6 is 12, and then 12 times 3 is 36. So our volume is 36 feet cubed. How about rectangular prism B? Volume equals length times width times height. Let's go ahead and plug them in. My length is 2, my width is 3, and my height is 4. 2 times 3 is 6, and 6 times 4 is 24. Rectangular prism C. Volume equals length times width times height. And so let's go ahead and solve it. My length is 3 times 5 times 10. 3 times 5 is 15. And 15 times 10 is, well, volume equals 150 feet cubed. And the last one, volume equals length times width times height. So my volume is 5 times 3 times 7. So 5 times 3 is 15. Times 7 is 105 feet cubed. Oop. That's 105 there. All right, so what do we need to figure out? The greatest volume. Well, obviously you can see that 150 has the greatest volume out of the 4 prisms. So my answer choice would be C. Now, you did have to do a lot of work there, but that's just kind of the part of the process of these types of problems. All right, let's look at number 2 here. The dimensions of 4 rectangular prisms are shown. Identify each of the prisms for which the maximum amount of sand the prism can hold is 48 cubic inches. So what this question is saying is we need to figure out the volume of these 4 figures. And then we need to figure out what is the maximum, the most amount of sand that the prism can hold is 48 cubic inches. So the most that any of these 4 can hold is 48. That's what we're trying to figure out. All right, let's just go ahead and call them A, B, C, and D. Let's just go ahead and concentrate on A first. We need a length, a width, and a height. So I'm going to go ahead and label my length, my width, and my height. So let's go ahead and pop it into our formula. Volume equals length times width times height. So my length is 12, my width is 2, and my height is 2. If we calculate that out, 12 times 2 is 24, times 2 is 48. So 48 inches cubed. Now, if this prism holds 48 inches cubed, isn't that the maximum amount that it could hold? Well, yes. So therefore, A is an answer choice. Now, I can't stop there. I actually have to go ahead and solve them all. So let's go ahead and do B. Volume equals length times width times height. I'm going to go ahead and label them real quick. I'm going to say that 3 is my length, 2 is my width, and 6 is my height. So let's go ahead and plug them in. Go ahead and do that. 3 times 2 times 6. 3 times 2 is 6. 6 times 6 is 36 inches cubed. Now, if this prism holds 36 inches cubed, does that have a maximum amount of 48 inches cubed? Well, no. So B cannot be one of our answer choices. Let's try C. Volume equals length times width times height. Notice how I'm writing my formula down every time. It's very important. So my length will say is 2, my width, and my height. There we go. So my length, here we go, 2 times 6 times 8. 2 times 6 is 12, and 12 times 8 is 96 inches cubed. Way too much. Not an answer choice. And let's check our last one just to be sure. Volume equals length times width times height. All right, my length, let's say we'll say it's 2. My width is 6, and my height is 4. So here we go. 2 times 6 times 4. 2 times 6 is 12, and 12 times 4 is 48 inches cubed. All right, that is another answer choice. So in this example, you actually had 2 answers that were correct. So that's the importance of actually going through each one to make sure that it is or it is not an answer. All right, I have 2 more application problems for us. Let's take a look at this question. This is kind of cool. The container at the Heinz factory is filled completely with delicious ketchup. Which of these represents the total number of cubic inches of ketchup in the container? So here's the picture of the ketchup to the right. You can see that it has a diameter of 6 feet and it has a height of 15. So remember, we need to know the volume, and to know the volume of a cylinder, we need to know the formula. Volume equals, remember, pi r squared times height. So what's very important about this is that we need to know the radius. The problem gives us the diameter. So let's go ahead and just figure this out. The radius here is going to be 6 cut in half, which is 3 feet. So now I'm going to use that number instead of the 6 feet. Now let's figure out which one of these formulas represents this volume equals pi r squared times height. If you look at A, doesn't look quite like that. Now B looks a lot like the right formula, but let's look at this. 6 squared, isn't that taking the diameter and squaring it? So that can't be right. So A and B are not correct. How about C? Pi 3 squared, isn't that a radius? Times height. It looks like C is a correct answer. And D, well, D is not even in the ballpark. All right, the last question I have for you. Determine the volume of the figure below. So you can see here that we have two different prisms. We have a cylindrical prism and we have a rectangular prism. We need to figure out how much water or sand can fill up these two containers here. So it looks like we need to separate it into two different problems. Let's go ahead and first take the cylinder. Let's take the cylinder and let's go ahead and figure out the volume. Remember, the formula is volume equals pi r squared times height. So let's go ahead and plug our numbers in there. We have a height of 10 and we have a radius of 3. So we have 3.14 times our radius squared times a height of 10. Let's go ahead and do our PEMDAS. So we're going to do our 3 squared first. 3.14 times 9 times 10. Be careful not to say that 3 times 3 is 6. It's a very common mistake. I'm going to go ahead and do 9 times 10 first because I know in my head that that is equal to 90. And then I can simply, in my calculator, take 3.14 and multiply it by 90. That will give me a volume of 282.6 centimeters cubed. Now, I'm not done. Now I need to figure out the volume of my rectangle. So let's go over here. And I know that the volume of my rectangle is V equals length times width times height. So I've got my length, I've got my width, and I've got my height. So let's go ahead and fill those numbers in there. Length of 15, width of 5, and a height of 7. I'm going to go ahead and do 15 times 5 first. And that's going to give me 75. And then I'm just going to multiply that by 7 to finish off the problem. That's going to give me 525 centimeters cubed. Now, I'm not done. What I've done there is I figured out the volume of the cylinder and I figured out the volume of the prism. Now, let's go ahead and add them together. So now what I'm going to do is I'm going to take 282.6 and I'm going to add it to 525. That's going to give me the total volume of the two prisms together. And I'm going to get that to be 807.6. And of course, that's also going to be centimeters cubed. So that's how many centimeters cubed can fit into this figure to the left. All right, that brings us to the end of our lesson on volume.